Today we are going to discuss a device that normally used to accelerate the charged particle, and the device is known as cyclotron. This device is working with the principle of that when a charged particle is entering into the magnetic field applied there perpendicularly, then the speed of the particle is increasing or is accelerating continuously, and those charged accelerated particles can be used for various experiments. So here from the diagram we can see that two metal discs D1 and D2, they are called as Ds. Why? Because they are called as Ds, their structure is similar to the English alphabet D. Is a magnetic field is applied. Here the direction of the magnetic field is in this direction, and a charged particle is kept here in the middle of these two Ds, and these two Ds are then connected to an oscillator, and the oscillator is used to produce an electric field in between these two Ds. Oscillator is working in such a way that the frequency of the charged particle is equal to the frequency of the oscillator. So the polarity of the oscillator is changing after a half cycle. Then here first it is connected to the positive terminal when the direction of the electric current is towards this direction, and the other end is connected to the another D which is negative. And here a charge is kept here, and here this is the way through which the charged particles with maximum speed is taken out and can be used. And why this electric field is produced by the accelerator or the oscillator? So when a charged particle is kept in the electric field, a force is exerted on the charged particle, so that force can accelerate the speed of the particle, and here we can accelerate it repeatedly inside the disc, and then with the maximum velocity, the particle with the maximum velocity can be taken out through here and can be used. And let us see the principle of this cyclotron. And we have already learned that when a particle is entering perpendicularly to the magnetic field, it follows a circular path. And the time period of this circular path is T is taken as, and T is 1 by nu c, that is the reciprocal of the frequency, and T is equal to 2 pi m divided by q. From this equation, and the frequency of this cyclotron then can be written as qb divided by 2 pi m. So that means the frequency of this cyclotron is equal to the frequency of the charged particles, and here the time period, and we have already learned that the time period of this circular path followed by a charged particles under the influence of magnetic field, independent of the radius and speed of the particle, the time period of the charged particle will remain constant. It does not change. That means the frequency of the particle is equal to the frequency of the oscillator, so that the oscillator can accelerate the speed of the particle as it moves inside the disc. And also we have learned that the radius of the charged particle following the circular path R is equal to mv divided by qb. Radius. And from this equation we have already formulated that the radius of the particle is directly proportional to the speed of the particle. That means when the speed of the particle increases, what will happen to the radius of this charged particle, the radius also will increase. So they are directly proportional to each other. And these two assumptions we are going to use in this cyclotron. So here the magnetic field applied here is to keep or to maintain the circular path of the charged particles, and the electric field applied here, which is applied with the help of this oscillator, is used to accelerate the particle continuously inside this cyclotron. And as if the charged particle moves and it increases the speed, so it increases the radius, and finally when the radius of the charged particles is almost equal to the radius of this disk, then it can be taken out through the structure and to hit on the target. The working of cyclotron is, so as I said, the charged particle is kept in the middle of this cyclotron, and when this particle is entering perpendicularly to the direction of the magnetic field, then what will happen? These charged particles will move circularly, a circular path. It follows a circular path, and from it adheres to the D2. Okay, when it is kept in the influence of this electric field produced by this oscillator, a force will exert on the particle and will enter to this D2 with a velocity, with a speed v. So as it enters into this D2, what happens? Then the direction of this velocity or speed of the particle is perpendicular to the direction of the magnetic field. So then it will follow a circular path. Okay, and follow the circular path and it will move to the end of the D2, and as it moves, there is a gap in between D1 and D2. As it about to go out of this D2, what happens? The oscillator connected to the D2 and D1. Here, the D2 is become positive and the D1 become negative. So the direction of the electric field will be from D2 to D1. So due to the electric field produced here, a force will exert on the charged particles. So as it force exerted, then the D2 will be entering to the D1. So as soon as it enters the D1, what happens? Then it is entering perpendicular to the magnetic field. So then the force exerted on the particle will be maximum, and then it will follow a circular path. Okay, and it follows the circular path, and the radius and time period of this particle as it moves from this in the D is T and R. T is equal to 2 pi m divided by qb, and R is equal to m v divided by qb. So as it moves from D to D1, so the speed of the particle is increasing as we compare the speed of the particle in D2. Why? Because an electric field produced here that will exert a force on the particle, and that force will accelerate the particle. It will increase the speed of the particle. So again, the magnetic field causes a circular movement for the particle, and it reaches the end of this D1. Again, as it goes out of D1, then again it will comes under the influence of the electric field. And now the direction of the electric field will change here. Okay, and D1 will be the terminal which is connected to the D1 become positive and D2 become negative. So the direction of the electric field from D1 to D2. So as it goes to this electric field, then a force will exert the particle, and so it will accelerate the particle. Then as it enters the D2, then the particle will be accelerated. That means the speed of the particle will be increased than before. So this process continuously takes place. The polarity of the oscillator changes in order to produce the electric field here, so that in order to change the direction of the electric field, so that the particle can exchange or it can move from one D to another one accordingly. And also the magnetic field produced here also makes the particle to move in a circular path, and this repeatedly the particle is repeatedly accelerated when the particle attain the radius of this, almost the radius equal to the radius of the D, then the particle can be taken out to this structure and can be used to hit on the target. And this is how a cyclotron works. So as I said, the frequency of the particle and the frequency of the cyclotron is maintained equal with the help of this oscillator. As we have the radius of the particle is R is equal to mv divided by qb. Then if the radius is taken as R, then what will be this equation? This equation will be mv divided by qb. And from this equation, and we can get the speed of the particle, that is v is equal to, from this equation we can get v is equal to qbr divided by n. And also we know that the kinetic energy, so here the particle is moving with a velocity and which is continuously accelerated, then it has a kinetic energy. And what will be the kinetic energy of the particle in the cyclotron? The kinetic energy can be written as, we know that the kinetic equation for the kinetic energy is equal to half mv square. And if we substitute the value of v in this equation, so we will get m into v. What is v? qb r divided by m. So we will get q square b square r square divided by m square. Then this m will be cancelled. So we will get the equation for kinetic energy is equal to q square b square r square divided by qm. This will be the kinetic energy of the particle in the cyclotron. So the cyclotron has some limitations and it has some uses also. And one of the limitation of cyclotron is normally used to accelerate the charged particles. But cyclotron cannot be used to accelerate the particle like neutron, because neutron has no charge. So uncharged particles cannot move, or it cannot influenced by electric field or magnetic field. Therefore, uncharged particle cannot accelerate with the help of cyclotron. Another limitation of cyclotron is it cannot be used to accelerate the particle like electron, because the mass of the electron is very small. So therefore, when this particle is accelerated inside the cyclotron, due to its less mass, the particle will be accelerated highly. So that what happens, since the mass is very less, then the particle will be collide inside this cyclotron and will be absorbed. Therefore, particles like electron having less mass cannot be accelerated by using cyclotrons. And some of the uses of cyclotrons are used to study in nuclear reactions, since it is related to these charged particles, and it can be used to study about the nuclear reactions. Cyclotrons is also used to implant the ions in the solid materials, and when the ions are implanted in the solid materials, the properties of the solid can be improved. So cyclotrons are used to implant ions in the solid materials. And another use of cyclotron is by using the cyclotron, so the charged particles can be accelerated. So the accelerated particle can use to start nuclear reactions. And also with the help of nuclear cyclotrons, or such as the radiation produced by this accelerated particle can be used to diagnose and for the treatment of various diseases. So these are the uses and some limitations of the cyclotrons, and I hope you understand.